This presentation critically reflects on the data-driven decision-making used throughout a Year 6 financial mathematics unit. The created unit of work has been designed for a cohort of Year 6 students and is 5 lessons long. The unit satisfies the Australian Curriculum Content Descriptor, which asks students to investigate and calculate percentage discounts of 10%, 25% and 50% on sale items, with and without digital technologies. Critical reflection is an extension of critical thinking. It asks us to think about our practice and ideas, and then it challenges us to step back and examine our thinking by asking probing questions. It asks us to not only delve into the past and look at the present, but more importantly, it asks us to speculate about the future and act. For the design and implementation of this mathematics unit, a cycle of professional inquiry has been used. This presentation reflects on the following phases of the inquiry cycle in regards to student learning and teacher practice. 1. The collection of data on student achievement. 2. The formation of goals created from the data. 3. The identification of knowledge and skills required as part of my teaching practice. 4. The engagement of students in new experiences. And 5. The impact this unit has had on student achievement. Knowing what students know is a critical component of effective classroom practice. If teachers know what students understand, they can more efficiently help students integrate new ideas and transform conceptions. A pre-test was chosen as a data collection instrument before the design of this unit. It was chosen because it provided a simple analysis of student achievement that could effectively be aligned with curriculum achievement levels. Each question from the pre-test was reflective of a specific achievement level, together forming an example of diagnostic teaching. Diagnostic teaching is commonly used in mathematics, allowing teachers to divide specific skills as a way to determine which specific content needs to be taught. This was useful for identifying knowledge gaps that would affect the integration of new ideas. For example, having a knowledge gap in something like rounding or decimal subtraction, a Year 3 concept, would directly impact a student's ability to exceed with calculating a percentage discount, a Year 6 concept. In this way, the pre-test is used to leverage assessment activities for formative purposes, like planning lessons, grouping students for instruction, and diagnosing strengths and weaknesses. Data collected from the pre-test was compared using this table, providing a whole class snapshot of students' current financial mathematics achievement. Displays like this are an effective way to keep records of student progress. If a box was coloured green, a specific skill was demonstrated. A yellow box indicated it was partly demonstrated, and a red box indicated no understanding was demonstrated. As expected, the table showed that students had little to no knowledge of how to calculate a percentage discount. This was expected considering the skill had not been specifically taught yet. Rather surprisingly, the pre-test demonstrated that many students were at a Year 3 or 4 level of achievement, being that they had difficulties rounding dollar amounts, calculating change, and solving multiplication and division algorithms. Through this process, it became obvious that the purpose of classroom data is not just to evaluate students, but is a means of diagnosing problems and analysing solutions. Not only would this data be important for designing the unit plan, it would be useful for gauging the success of the teacher's practice. From the pre-test, clear goals were developed, which went beyond the focus of the unit that was to teach students to calculate discounts. The data showed that skills regarding rounding, subtraction, multiplication and division needed further development in students and would thus be part of the unit's eventual design. Using the data collected in the pre-test and teacher observations leading into this practical placement, a unit of work was created that followed this progression of learning. Initially, students would learn that percentages are related to fractions and decimals. Then, they would practice using effective mental computation skills for finding 50%, 25% and 10% of a dollar amount. and eventually move on to finding the sale price by subtracting the found percentage. A variety of formative assessments were developed to assess student understandings during and after lessons, and resulted in multiple adjustments to lessons to ensure conceptual understandings. The development of adaptive expertise requires reflection in order to accomplish the complex combination of noticing, analysing, and most importantly, taking action supporting students. Initially, percentages were taught in this unit using grid squares as a resource. In this unit's design, manipulatives like grid squares challenge students to physically divide the units of a 100 square, thus building the connection between a percentage, fraction, and decimal. While this is considered best practice for teaching a new mathematics concept, it appeared the process of dividing a dollar amount by 10 to find 10%, like one would with a grid square, was difficult for students. To remedy this problem, the teacher supplied an impromptu lesson on dividing a total by 10, and added an alternative strategy for calculating 10%. Alternative strategies give the student the opportunity to compare solutions, and as a result have been shown to be particularly effective for supporting procedural flexibility. For a majority of students, moving the numbers of a decimal a place to the right represented an easier solution to finding 10%. With experience, teachers can become adaptive experts who are adept at identifying instructional roadblocks like this. By the end of this unit, this method appeared more often in students' work and assessments. Summative assessment in this unit was conducted using a question-and-answer test, similar to the initial pre-test. In this way, student progress could be compared and measured more readily. The test itself was designed to reveal which particular skill or achievement level students did or didn't reach. One criticism of exams like this is that there is limited opportunity for higher order thinking, and perhaps student achievement could have been better served if there was some kind of alternative assessment included in the planning. Alternative assessments have the potential to yield equitable assessment practices through multiple assessment strategies that reveal the strengths of a greater variety of students. Each question from the assessment coincided with an achievement level built into the rubric. Initially, each question was given an A to E grade, but this was altered during the moderation phase of this unit, and will be discussed in the moderation section of this presentation. Student responses to test questions were collected for moderation to conclude this unit of work. The purpose of social moderation is to produce valid and reliable judgments that are consistent with achievement standards. This involved 3 teachers from across grade 6 coming together with selected samples of student responses that they believe are reflective of an A to E level answer. This type of social moderation is similar to a calibration model of moderation. A calibration model involves teachers selecting samples and comparing them until a consensus is reached. The rubric created for this test originally gave each question an A to E scale, but through the process of moderation it was decided that there were many questions that were not representative of an A-level response because they tested skills below grade 6 achievement. In response, the rubric itself was altered so that the maximum achievement level a student could score for a simple skill like rounding or addition was C. Through this experience, it became evident that the social moderation of assessments, while appearing time-consuming, actually has the potential to save time, being that a common understanding for each achievement standard improves marking efficiency and reliability. A positive impact on student achievement has been displayed as a result of the implementation and assessment of this unit of financial mathematics. Each of the 3 student samples collected for individual analysis were of a C level of achievement, when initially, according to the pretest, they displayed characteristics of D students. Findings have indicated that students who had limited understanding of discount percentages could now calculate 10%, 25%, and 50% of a dollar amount. These same students were even able to demonstrate in their summative assessment some skills found in the Year 7 curriculum, like the calculation of best buy problems. In these instances, it could be assumed that the teaching practice used had a positive impact on student achievement. But not all findings were positive. It was also found that according to the final exam, the cohort of Year 6 students were weakest calculating discount problems using their calculators. It is the opinion of the pre-service and mentor teacher that calculator skills were somewhat taken for granted during the implementation of this unit. It was assumed that calculator skills were easier than non-calculator skills, and as a result, less time was allocated to teaching calculator operations, when in fact digital skills are very important in high school and the wider world. This critical reflection on data-driven decision-making has resulted in a greater understanding of student learning and a more holistic appreciation of what makes an effective teaching practice. The data instruments used to design this unit were successfully leveraged for formative purposes. They were in turn collated to inform the design of the mathematics unit so to maximize its impact on student learning. Its implementation into the classroom has been shaped flexibly by both formative and summative assessment. As a whole, the unit has had a mostly positive impact on learning. Through the process of critical reflection, has improved the depth in which this teaching practice has been thought about.